Hello students, welcome back to yet another session. We will discuss instruction set, and also I am taking the instruction set of 8085, and it is the CISC type complex instruction set, and here we can discuss all the instructions, and a similar type of instructions are present in 8051 microcontroller. In another PIC microcontroller, it is only 34 instructions. You can easily remember them. And here we are going to complete this topic in this session. Instruction set. So in next session, let us discuss timing diagram and then applications in automation systems. You can see this is the complete instructions, 74 instructions. It is known as hexadecimal code, CEP8F. In a microprocessor, we are going to enter hexadecimal code for each instruction. So here this is mnemonic, it is known as mnemonic, ACI, ADC, ADC-B, ADC-C. So we have all these instructions, 74 instructions, and we can group all these instructions into different sets. So that sets we are going to discuss in today's session. So here in exam, unfortunately you do not have this in our laboratory exercises. If the laboratory experiment to be performed by you, then you have to write the program using mnemonic code, and then for each mnemonic you have to find. So this is known as opcode sheet. This opcode sheet will be given to you in exam, and for your instruction, for each and every instruction, there will be a hexadecimal code. So the microprocessor will understand only this hexadecimal code rather than the instructions that you are learning. So, but for each instruction that you are writing in your program, you have to find the hexadecimal code from opcode sheet, and that only you have to enter in your microprocessor. Hexadecimal code only you need to enter in microprocessor. That's why I am showing you what is opcode sheet, and this is the opcode sheet, and you can get the opcode for every instruction that you are using in your programming. Only these instructions, not more than this. Any program that you wanted to write, you should limit yourself within this instruction set. So microprocessor programming, a program is a set of instructions arranged in the specific sequence to do the specific task. So this is simple way to define program. And programming is a process of telling the processor exactly how to solve a problem. So now for any problem you are going to write the program, and that program you are going to feed to your microprocessor, where you are telling the microprocessor to do some specified task through your programming. So that is the programming. A programmer must speak to the processor in a language which processor can understand. So the programming you are doing here, and that should be converted into hexadecimal code, and that code only the processor will understand, and that code you have to enter in the microprocessor. So in order to speak, language is the only mode of transmitting the information from one person to another person. Similarly here, the language that you know here is the instruction set of 8085. Using that you are going to speak with microprocessor. So steps involved in programming: specifying the problem, designing the problem solution, coding, debugging. So these are the steps in programming. How to develop a program logic, how to tell the program to processor, how to code the program. So these are the three. One more question: how to test program? How to test program? And these four tasks you have to perform while doing the programming. And a flowchart is a graphical tool that allows programmer to represent various actions which are to be performed. The graphical representation is very useful for clear understanding of the programming logic. So this is the another way to develop the programming logic. You are using the different symbols. I will show you symbols. So these are the symbols. Oval, it indicates the start of the operation. So this is oval. And you have arrow, it indicates flow with direction. And parallelogram, it indicates input output operation. And rectangle, it indicates process operation. And diamond, it used to indicate decision making operations. And a double-sided rectangle, it indicates execution of predefined process, so it may be a subroutine. And a circle with alphabet, it indicates continuation. And this A can be any alphabet, so you can use any convenient alphabet. So instruction formats. So 8085A instruction set consists of 1, 2 and 3 byte instructions. So 1 byte, the implied addressing mode we have seen CMA, so that is a 1 byte instruction. 2 byte with opcode and 1 data, and 3 byte it is normally address. So 2 bytes will be address and opcode will be 1 byte. So the first byte is always the opcode. So in 2 byte instruction, the second byte is usually data. In 3 byte instruction, the last 2 bytes present address or 16-bit data. And 1 byte instruction, so this is the format, one byte, only opcode, 1 byte. So move A comma B, so this is 1 byte, whose opcode is 78H, which is 1 byte. So this instruction copies the contents of B register in A register. So there is 1 byte instruction, 2 byte instruction, opcode and operand. So you will have one opcode and one operand. So move immediate B is opcode and operand is 02. So the opcode for this instruction is 06H. So from that sheet, in first sheet I have shown you, so that is nothing but 06H, and is always followed by 1 byte data, that is 02H. So 02H in this case. So this instruction copies immediate data into B register. So it is immediate addressing mode. And a 3 byte instruction, the format is opcode, operand and operand. So opcode is normally the instruction, and operand it may be either 16-bit data or it can be address. So JMP, that is JMP 6200, the opcode for this instruction is C3H. So C3H. So C3H is you can find from that table I have shown you in first slide, and is always followed by 16-bit address. So 6200H in this case. And this instruction is 3 byte instruction which loads a 16-bit address into program counter. So PC, that is program counter. So 8085 instruction set can be categorized into 5 different groups. So now all 74 instructions you can categorize, you can group them into 5 groups. So one is data transfer group, arithmetic group, logic group, branch group, stack input, output and machine control group. So here these are the 5 groups. So all 74 instructions we are going to discuss here, and each instruction can be categorized under these headings. And notations you can see here. M is memory location pointed by HL register pair, it is also known as memory pointer. And R is 8-bit register, 8-bit general purpose register. RP is 16-bit register pair, and RS is source register. RD is destination register, and ADDR is 16-bit address. So ADDR is nothing but address. It is normally 16-bit in size. So these are the notations. So all of you please remember these notations in order to remember all 74 instructions. So out of 74 instructions, any instruction can be a 2-mark question, or a group of instruction can be 5-mark question, or it can be 10-mark question also. So please remember, very easy to remember all these instructions. No need to worry at all. So first one is data transfer group. So first one is data transfer group. So there are 13 instructions under this category. It loads the given data into register, copy data from register to register, and copy data from register to memory location, and vice versa. So this is the data transfer group. Data is transferred from one source to another destination, or from destination to source, vice versa, whatever way we need or required, we can transfer it. So these instructions do not affect any flag in the flag register. So in 8085 architecture itself, I have explained what is flag. Flag register is also known as status register. So it never affect any of the flag, because it is only transferring data from one place to another place. That's all it is doing. So that is why no flag is affected. There is no change in status of any operation with these instructions. So the first one is move immediate r comma data. So that is 8-bit data, and mvim comma data, and mov rd comma rs, mov comma rs, MOVRD, M, LXI data 16-bit, so STEA address, LDA address, SHLD address, LHLD address, stacks address, LDAX RP, and last one is XCHG. So this is exchange operation. So here these are the 13 instructions. We will see one by one, and any one can be a 2-mark question, or all this group can be a 5-mark question, or it can be even 10-mark question. So the first one is move immediate r comma data. Already we have seen the move immediate r comma data in earlier topic also, addressing modes. Move 8-bit immediate data to register. So operation is 8-bit data to register. So from right hand side to left hand side. So in almost all instructions, so the data flow from right hand side to left hand side. Please remember that. So this data is stored in R. Only the instruction that start with the S letter, students, it is a one blind rule you can remember easily. The instruction that start with the S letter, there the data flow takes place from left hand side to right hand side, so opposite to this. So now it is happening from right to left, and the instruction that starts with S letter, I will show you those instructions. So in that instruction itself, only in those instructions, please assume that, or you can confirm it, that the data flow takes place from left hand side to right hand side. So here the 8-bit data is stored in register R. It can be A, B, C, D, E, H and L. So these are the registers. So now this instruction directly loads a specified register with the 8-bit data given within the instruction. The register R is 8-bit general purpose register, such as A, B, C, D, E, H and L, and the number of bytes, it is 2 bytes. First byte is opcode MVI, R. Second byte is 8-bit data. And addressing mode, immediate addressing mode, and flags, no flag is affected. So for all these 13 instructions, no flag is affected. So for example, MVIB, 60H. So 60 is directly stored in register B. So this is the first instruction. So then second instruction, MVIM, data. So it is the M is nothing but the memory pointer. It is actually HL register pair a address is stored in memory pointer. In that address, it is pointed to some address. In that address, the data is moved from this data is moved to that address pointed by HL register pair, and move 8-bit data to memory whose address is in HL register pair. So operation is the byte, that is HL register pair data is moved to the address that is pointed by M register, that is memory pointer HL register pair. So this instruction directly loads an 8-bit data given within the instruction into a memory location. The memory location is specified by the contents of HL register pair. So number of bytes, 2 bytes. The first byte is opcode MVIM and second byte is 8-bit data. Addressing mode immediate, and indirectly you are accessing the memory location, so that is why it is indirect addressing mode. It comes under, it belongs to both type of addressing modes, so that is immediate addressing mode as well as indirect addressing mode. So flags are not affected. Move immediate M, 40H, H equal to 20, L equal to 50. So H is stored with 20 and L is stored with 50H. So now the instruction loads 40H into memory whose address is 2050, that is 2050. So now the 2050, L to 50 and H to 20H. So there is 2050 address. So 2050 H address that is pointed by HL register pair. So that is the second instruction. The third instruction, move RD, RS. So register to register, that is why it is register addressing mode, and data is moved from RS to RD. So now the it is 1 byte instruction, register addressing mode, flags are not affected. A equal to 20, A is having 20, move B, A. So now from A to B, so always right to left as I said, and the data from A is stored in register B. So that is register B. So next is move M, RS. It is indirect addressing mode. It is indirect addressing mode, and the same. The working, everything is same as earlier. No flags are affected. Next instruction is move RD, M. So whatever address is specified by this HL register pair, and in that address some data is present. So that will be stored there, that will be moved to RD. So now indirectly you are accessing the memory location. That is why it is indirect addressing mode. No flags are affected. So that is the fifth instruction. And sixth one is LXI RP, data. This data is X. Wherever you have X, it is actually operating the RP register pair, and data is 16-bit data, and the RP is register pair, and it is capable of storing 16-bit data. So it is LXI. So I is present, it is immediate addressing mode. No flags are affected. So here LXI-B, 1020H. So this instruction will load 10H into B register and 20H into C register. So this is the LXI B, 10, 20, 10 20. So now the 10 is load in the first register, that is B, and next register is C, and this 20 is stored in C. So that is the data is stored immediately into register pair. Register pair is BC, and no need to mention C here, it is only B, and this is one example. You can give example for each instruction, so that will fetch you full marks. So here you can see, students, STA address. So yes, it starts with S. So from accumulator to address. So from left hand side to right hand side. So that's why I given you that blind rule to remember easily. and it is also store accumulator contents into the given address, and it is direct addressing mode. Flags are not affected. For example, A is having 50H, so that will be stored in the address 2000. 50 will be stored in 2000 memory location address. LDA address. So now it is opposite to STA address, and here the whatever is there in this address, so that will be stored in accumulator. That will be stored in accumulator. So now this accumulator is holding the data, right? So whatever address is this address is having the data, that will be stored directly into the accumulator. So now it is belonging to direct addressing mode, and now the 2000 is having 30H, so that 30H will be stored in accumulator from right to left. So that is the LDA 2000H. SHLD, it is another very important 2 mark question, students, and here the SHLD store HL register pair in the memory. So that this is the address is first byte is in L, and next byte is in H. So this instruction stores the contents of L register in the memory location given within the instruction, and the contents of H register at address next to it. So now this is as simple as this. It is a 3-byte instruction. First byte is opcode SHLD, second byte is low order byte of the address, the third byte is high order byte of the address, and it belongs to direct addressing mode, and flags are not affected. For example, H is having 30 and L is having 60 and SHLD 2500. So now the instruction will copy the contents of L register at address 2500H and contents of H register at address 2501H. So now this is how the data will be stored in HL register pair. So now this is the direct addressing mode and no flags affected. So this is a special type of instruction, SHLD. And then similarly we have LHLD. So that is the next instruction, LHLD. Load HL register pair from memory. So L address is in L and address plus 1 is stored in H. So that is the LH register pair, and it is also 3-byte instruction, and direct addressing mode flags are not affected, and LHLD 2500H. So 30 is stored in 2500 and 60 will be stored in 2501 memory location. Stacks RP. So it starts with S letter, students. So now the accumulator contents are stored in the register pair. So accumulator contents is stored in register pair, and store the contents of A register in memory location whose address is specified by BC or DE register pair. So it is accessing register to register. That's why it is register addressing mode, and also indirectly you are accessing the address through RP. So RP is containing the address. In that address you are going to store the accumulator contents in that address. So that is why it is indirect addressing mode. So now BC is having 1020H, A is having 50. So this is the memory location. The contents of A, that is 50H, will be stored in this address 1020 address, that is pointed by BC register pair. So that is STAX RP. Then LDAX RP, it is very similar to the earlier operation. It is also register indirect addressing mode, and whatever contents you have in DE register pair, and that will be stored. the whatever contents are there in the register pair address, so that will be stored in, that will be loaded into accumulator. So that is LDIX RP. LDIX RP is very similar to the STIX RP, the data flow from RP to A in case of LDIX, and in that STIX from A to RP address, in that address A contents will be stored. So that is only difference. Next is exchange type, that is exchange XCHG. Exchange the contents of H with D and L with E. So there is no register is specified here, but it is the meaning of XCHG. Always the exchange contents H with D, L with E. So that is exchange, and D contents are exchanged with H, E contents exchanged with L. So now it is accessing the register to register only. So it is register addressing mode, and D is having 2040, HL is having 7080. After execution, H is having 20, and L is having 40, D is having 70, and E is having H0, 80. So this is the exchange of contents, between HE and DE, HL and DE register pairs. So that is it is a very special type of instruction, and also very important type of instruction. So these are the 13 instructions in data transfer group, students. Next group is arithmetic group. So arithmetic group we discuss here. In arithmetic group, instructions add, subtract, increment, decrement data in registers or in memory. In addition, there is one instruction which adjusts 8-bit data to form BCD numbers. So that is a special type of instruction. In add, there are actually 6 instructions, including this special instruction. There are 7 instructions in total. We will discuss all those 7, and then the addition. First we see addition. Similar to addition, we have subtraction. So subtraction is same as addition only. We will see those also. So these are the 7 instructions. Add R, add M. M is actually memory pointer. It is HL register pair specified by HL register pair. ADI data 8. ADC R, ADC M, ACI data, DAD RP. So this is the special type of instruction. So add R, so whatever the contents are there in R, that will be added to accumulator contents, and the result will be stored in accumulator again. So that is add R. So this is one arithmetic operation. So here it is register addressing mode. All flags are affected since we are manipulating the data in the registers. So flags will be affected from hereafter. So in earlier data transfer group, no flags were affected, whereas from hereafter all flags will be affected. And here A is 20H, C is 30H. So ADDC, and the contents of 30 C register will be added to accumulator contents, and the result again will be stored in accumulator itself. So that is 50H will be stored in accumulator. So that is the first one. Next, add M. The contents of the memory location that is pointed by HL register pair will be added to accumulator contents. Again, the result will be stored in accumulator. So that is the add M. So here you can see register indirect addressing mode, all flags are affected. A is having 20 and HL is having 2050 address. In that address we have 10 data, 10. So this 10 is added to 20, and again this 30, the address, the result 30 will be stored in accumulator again. So that is Adam. ADI data 8-bit data. So here the all flags are affected, immediate addressing mode. A is having 50 and ADI 70. So 70 plus 50 will be stored, that is COH. CO is the result, that is hexadecimal number, that will be stored again in accumulator. So that is add ADI data. So it is immediate addressing mode. So next instruction is ADC-R. So now ADC with carry. So add register R with carry to register A. So carry, the contents of register, everything is added to accumulator contents, and again the result will be stored in accumulator itself. So accumulator itself, so that is ADC R. So it is also register addressing mode, and all flags are affected, and here the A flag carry flag is 1, and A is 50, C is 20, 50 plus 20 plus 1, so that is 71, H will be stored in accumulator. ADCM and add data in memory to accumulator with carry. So same very similar to earlier one. The contents of address location, that is pointed by HL register pair, will be added to accumulator contents, and also carry will be added, and 30 plus 20 plus 1 equal to 51H. Again this result is stored in accumulator itself. So that is very important point, students, remember that. ACI data. So ACI data, add 8-bit immediate data to accumulator with carry. So the operation here is 8-bit data with carry is added to accumulator contents. The result again stored in accumulator itself. Then DAD RP. So this is a special purpose, special type of instruction. So special type of instruction, add register pair RP to HL register pair, and again result will be stored in HL register pair. So this is DAD RP. This instruction adds the contents of specified register pair to the contents of HL register pair and stores the result in HL register pair itself. So it acts like accumulator. It is very similar to accumulator. The RP is a 16-bit register pair such as BC, DE, HL, or even stack pointer can be used as RP, and only higher order register is to be specified for register pair within the instruction. So that's what we are doing in all register pair representation. So it is 1 byte. Only carry flag is affected. DE 20 10 20, HL is 2050. This instruction will add the contents of DE register pair, so 10020H, to the contents of HL register pair 2050H, and it will store the result 3070H in the HL register pair itself. So this is DAD RP. And next these are the addition instructions. Next we have subtraction instruction. Subtraction is as similar as your addition only. So this we are going to discuss the subtraction now. So subtraction, there are 6 instructions. Like DAD RP is not required for subtraction, only 6 instructions, very similar to that. So the working of all these 6 is same as addition. So that's why I am skipping this, and you can go through these instructions. So sub bar, next one is sub m, next one is SUI data, and you have SPBR and SPBM and SBI data. So next one is decimal adjust accumulator. So it is a the very important type of instruction, and it is used for BCD numbers. It is for BCD numbers. This instruction adjusts accumulator to packed BCD, binary coded decimal, after adding two BCD numbers. So it instruction works as follows. If the value of the low order 4 bits D3 to D0 in the accumulator is greater than 9, or if auxiliary carry flag is set, the instruction adds 6 to lower order 4 bits. If the value of high order 4 bits D7 to D4 in the accumulator is greater than 9, or if carry flag is set, the instruction adds 6 to the higher order 4 bits. So this is DAA, decimal adjust accumulator. So decimal place is adjusted here in order to form BCD numbers. So it is especially used to add two BCD numbers, binary coded decimal numbers. So this is the very implied, it comes under implied addressing mode as well, and it is 1 byte DAA. All flags are affected here also. So next is increment and decrement. So we will discuss increment, and decrement is same as increment. So there are 3 increment instructions and 3 decrement instructions. We will discuss increment instructions first, and then decrement is same as increment, that you can go through this material. So first one is INRR. INRR, increment specified register. So increment means it is the contents will be incremented by 1, right? So adding 1. So this instruction increments the contents of specified register by 1. The result is stored in the same register itself. So the register R is 8-bit general purpose register A, B, C, D, E, H and L, and it is a 1 byte instruction, register addressing mode. All flags except carry flag are affected. B equal to 10H. So this instruction will increment the contents of register that is 10H by 1 and stores the result, that is 11, in the same register B. So that is increment R. And increment M. So the contents of memory location pointed by HL register pair will be incremented by 1. So that is memory plus 1, and it is same as earlier one. The 2050 is having 30H, and this content will be incremented by 1, so that will become 31H. So that is INR M. INX RP. So RP contents, register pair contents, will be incremented by 1, and here no flags are affected, and register, it comes under register addressing mode. So similarly we have sub, that is decrement R, we have decrement M, and we have decrement RP. So then these are the increment and decrement group, and then we have branch group. Next one is branch group. So next type of instructions are branch type, branch group. So here there are 3 types of instructions again. One is jump instructions, call and return instructions, restart instructions. These are the group instructions allow the microprocessor to change the sequence of a program either unconditionally or under certain test conditions. This group include jump, call and return, and restart. So here jump, there are 3 instructions. One is JMP address, J condition address, PCHL. So these are the 3 instructions. So the first one is jump instruction, jump address. So jump unconditionally to the address. Jump unconditionally to the address. So here operation is PC, that is program counter. So here program counter plays the major role, because the address is the program execution flow is actually having is tracked by the program counter. So address is stored in program counter. So here this instruction loads the PC program counter with the address given within the instruction and resumes the program execution from this location. So now jump address, I am specifying some address. Now my program execution will go to that address directly. Now it is a 3-byte instruction. Opcode is jump JMP. Second byte is low order byte of the address. Third byte is the high order byte of the address. It is immediate addressing mode. Even though you don't find I letter here, it actually comes under immediate addressing mode. Flags are not affected. So this is a jump instruction. Then we have jump conditional address. So now the jump conditionally to the address. If something is happen, then it will go to that address. If condition is true, the program counter, the address will be stored in program counter. Else it will skip that and it will go to next instruction, that is PC plus 3. So now these conditions are JC jump on carry, JNC jump on not carry, and JP jump on positive, JM jump on minus, JPE jump on parity even, JPO jump on parity odd, and JZ is jump on 0, and JNZ jump on not 0. So these are the conditional conditions. So upon these conditions, this jump condition address will work. So here it is number of bytes are 3. The first byte is opcode of J condition. Second byte is low order byte of address. Third byte is high order of the address, and it also comes under immediate addressing mode. Flags are not affected, but flags are checked. So here carry flag is 1, and JC2000H, that is the instruction will cause a jump to the address 2000 when the program counter will load with the 2000H since CF is equal to 1. So carry flag is equal to 1. So this is the jump condition address. And then PCHL, next one is PCHL. So load HL contents into program counter. So HL contents is normally address, so that will be stored in program counter. So here this instruction loads the contents of HL register pair into the program counter, and thus the program control is transferred to the location whose address is in HL register pair, and it is register addressing mode. Flags are not affected. HL is equal to 6000H. After execution of this, the program counter will be loaded with 6000H. Then program loop instructions. So here initialization section, processing section, loop control section, and you have result section. These are the 4 loops you can have. So each loop have these 4 sections. The program loop is the basic structure which forces the processors to repeat a sequence of instructions. So here it is loop when the list of instructions to be executed, then you can use a program loop. These are the sections of program loop: initialization section, processing section, loop control section, result section. So these are the 4 program loop. And what is a program loop? It can be a 2-mark question. Logic group. So next one is logic group. So logic group, there are actually 15 instructions. So logic group instructions perform logic operations such as AND, OR, XOR, compare data between registers, or between register and memory, rotate and complement data in registers. So these are the 15 instructions: ANA, OR, ANA, M, ANI data. So these are AND XOR, R, XOR A, R, XOR A, M, XOR I data, and then we have ORA-R, ORA-M, ORI data, CMPR, CMPM, CPI data, STC, CMC and CMA. So these are the 15 types. So 15 types of instructions. So for AND operations we have 3, XOR for 3, OR we have 3, and compare 3, and ST, CMC and CMA are the 3 more instructions. So these are the if you know one operation, one logic operation, then same thing can be extended to other logic operations. So now AND-AR, so this is AND operation, and specifies the specified register with accumulator. So now the contents of accumulator and R will be ANDed. The AND operation is normally dot operation, and the result will be stored again in A itself. So here you can see it is a 1 byte instruction, and it is register addressing mode. All flags are affected with the carry flag equal to 0. Auxiliary carry flag is always 1. So A is having this data AAH, and B is having the 0FH. So this instruction will logically AND the contents of B register with the contents of accumulator. It will store the result, the 0AH, in the accumulator itself. So now the AND operation, after ANDing, so 1 0 equal to 0 and 0 0 equal to 0, 1 0 equal to 0 and 0 0 equal to 0. So 1 1 is 1, 0 1 is 0, 1 1 is 1 and 0 1 is 0. So that is AND operation. It is 0AH. So this 0AH, the after AND operation, the 0AH again will be stored in accumulator itself. Next is AND-M, same operation, and the contents of memory location that is pointed by HL register pair will be ANDed with the accumulator contents, and the result will be stored in accumulator itself. So it is also same as earlier one, but the register addressing mode is register indirect addressing mode. Addressing mode is register indirect addressing mode. So carry flag will set to 0 and auxiliary carry flag will set to 1. So this is the same thing for all AND operations. So ANI, it is ANI data, so and immediate data. So data is specified within the opcode, within the operand, and that will be ANDed with the contents of accumulator. Again the result will be stored in accumulator. So it is immediate addressing mode, and carry flag is 0, auxiliary carry flag is 1. So next is XRA, similar thing here. XR operation, exclusively different. When the inputs are exclusively different, the output will be high. So that is the carry flag is 0 and auxiliary carry flag is also 0. So all flags are affected, and register addressing mode, it comes under register addressing mode. Next one is XRA-M, and similar to XRA-R. So it is XR operation. The contents of memory location that is pointed by HL register pair will be ANDed with accumulator contents. Again the result will be stored in accumulator. So carry flag is 0, auxiliary carry flag is also 0. It comes under register indirect addressing mode. And then we have XRI data. So it comes under immediate addressing mode. All flags are affected. Carry flag equal to 0. Auxiliary carry flag is also 0. So then we have R operation. It is same. It is R operation. The contents of register R will be register will be ORed with A, and result again will be stored in A register. So that is ORA R, and then ORAM. So ORAM, it is same as the memory location that is pointed by memory pointer, that is HL register pair, and the accumulator contents and that memory location contents will be ORed, and the result will be stored in accumulator again. ORI data, it is immediate addressing mode, and all flags are set, carry flag equal to 0, auxiliary carry flag is also 0. So compare. So compare is compare specified register with accumulator, and here the flags are affected. Result of comparison can be obtained with the help of flags are as follows. If A contents are greater than R, carry flag is 0, 0 flag is also 0. If A contents are equal to R, carry flag equal to 0 and 0 flag is 1, and A contents are lesser than R, carry flag equal to 1 and 0 flag is equal to 0. And we have A equal to this number B8H, and D is equal to B9H, and this instruction will compare D register with the contents of accumulator. Here A is less than D, so carry flag will set after the execution of the instruction. So this is the compare instruction. Similarly, compare M. So the contents of memory location pointed by HL register pair will be compared with A, and the similar fashion the flags are set. Here it comes under register indirect addressing mode. CPI data. So it is very similar to the earlier one. The flags are set in the same fashion, and it comes under immediate addressing mode. So the data is specified within the instruction itself. So then STC and CMC, it is both are the set carry and complement carry. So after that we have CMA, complement A, and it actually complements the contents of A register, and the result will be stored again in A register. It is implied addressing mode, no flags are affected. Then rotate group. So rotate RLC, RRC, RAL, RAR. So these are the 4 instructions. RLC, rotate the contents through left through carry, and RRC, right through carry, RAL and RAR. So this is the RLC. So here the before execution you have this number, and rotate accumulator left, RLC, rotate accumulator left. So here the contents are now this 0 will go and sit here at B0. So B70 will go and sit here. So B0 will go to B1, B1 will go to B2, B2 contents will go to B3 through left. The contents will be rotated through left, and the 0 will come here. So 0 and 1 is coming here, 0 is coming here, 1 is here, and the left through left. It is the contents are rotated by 1 bit left. So then RRC, and it comes under implied addressing mode, RLC and RRC, implied addressing mode. So carry flag is affected, all other flags are unaffected. So here CY equal to 1. After execution the carry flag is set, carry flag will reset. RRC through right. So through right, rotate accumulator through right. So same way, and carry flag is affected, all other flags are unaffected. It also implied addressing mode. RAL accumulator, rotate accumulator left through carry. So here left through carry, the carry is also considered to rotate here, and this instruction rotates the contents of accumulator left by 1. So with carry, RAR, it is also with carry. And the stack operations, so these are special purpose operations, stack operations, LXI, SP, data and SPHL. So here push and pop instructions, call and return instructions, restart instructions, and STHL instruction, SPHL instruction. So the first one is LXI, SP, data and SPHL. It initializes stack pointer. So this is the direct way of initializing stack pointer. Indirect way is accessing HL register pair, and SPHL is also indirect way of accessing the stack pointer. SPHL moves data from HL to stack pointer, HL to stack pointer. So HL to stack pointer. It is 1 byte instruction. It is comes under register addressing mode. Flags are not affected. So push and pop. So here this is initial position. After decrements SP stores higher byte, and after decrements SP stores lower byte. So this is steps involved in push operation. So temporarily stores the contents of register pair and program internal status word. And push operation, in push operation 16-bit data is stored in the stack pointer. So push RP, push specified register pair onto the stack. So SP equal to SP minus 1. So SP RPH, SP minus 1, and finally SP will have RPL. So here this instruction decrements stack pointer by 1 and copies the higher byte of the register pair into the memory location pointed by stack pointer. So it will decrement by 1, and the contents of the memory location pointed by HL register pair will be stored on the stack pointer. It then decrements the stack pointer again by 1 and copies the lower byte of the register pair into the memory location pointer by stack pointer. The RP is 16-bit register pair such as BC, DE, HL, and higher order register is to be specified within the instruction. So it is a 1 byte instruction, and register indirect addressing. Flags are not affected. SP equal to 2000 and D equal to 1050, and here this instruction will decrement the stack pointer 2000 by 1. So that is SP equal to 1 FFH, and copies the contents of D 10H into the memory location 1 FFH, and then decrements the stack pointer again by 1. So SP equal to 1 FFE, and copies the contents of E register 50 H into the memory location 1 FFEH. So this is the stack push operation. Push PSW. So this is push program status word on the stack. So program status word is on the stack. So here it is a very special type of instruction. So here this instruction decrements stack pointer by 1 by accumulator contents into the memory location pointed by stack pointer. It then decrements the stack pointer again by 1 and copies the flag register into the memory location pointed by the stack pointer itself. So here it is a register indirect addressing mode. flags are not affected. So this is the push PSW, program status word, and pop instructions, pop operations. So now the lower byte is here and the higher byte is here. So SP will pop. So pop operation, 16-bit data is read from the stack. So it one by one, the stack pointer will read the lower byte and higher byte. It is the initial position. It increments stack pointer and reads the lower byte, and increments stack pointer and reads the higher byte. So these are the steps involved in POP operation, pop operation. So pop is also very similar to push operation only. So pop specified register pair on the stack and RPL plus 1, RPL plus 1. So that is the SP plus 1. So this is in case of push it is decrement minus 1. In case of pop it is plus 1. So that is only difference. Remaining register indirect addressing mode, flags are not affected. So it is program status word for pop operation, and then call and return operation. So call and return, it implements subroutines. So this is the main program, and you can call and you can return to next subroutine, and you can call to subroutine. You can execute this and then go to next instruction. So that is the call and return instruction. So call address and C condition address, call instructions and the C condition address. So call instruction, it call unconditionally a subroutine whose starting address is given within the instruction. So here within the instruction, if you specify it, it will go to that address and it will execute the subroutine and it will come back to its original address. So that is the call address, and there are instructions with conditions. So here it is a opcode call, and lower order byte, second byte is the lower order byte of the address, third byte is higher order byte of the address. Addressing mode is immediate and indirect addressing mode. Flags are not affected. Stack pointer is equal to 3000, then 6000H call 2000H. This instruction will store the address of next 6003H, that is call in onto the stack pointer PC with 2000H. So 2000H. Return from the subroutine unconditionally. So after execution of subroutine, it will go back to its original program counter and stack pointer, and now PCL SP PCH SP plus 1, SP is SP plus 2. So this is also 1 byte instruction opcode return. Then we have register indirect addressing mode, flags are not affected. Then we have condition address. So conditions are actually, we have CC, CNC, CP, CM, CPE, CPO, CZ and CNZ, and here C condition call the subroutine conditionally at given address. So this is the description. CC call on carry, and CNC call on not carry, and CP is call on positive, CM is call on minus, and CP is call on parity even, CPO is call on parity odd, CZ is call on 0, CNZ is equal to call on not 0. So this is these are the conditions. So written conditions are RC, RNC, RP, RM, RPE, RPO, RZ and RNZ. So these are the R written conditions. And restart. So restart instruction, this group consists of restart instructions RST, n can be 0 to 7, and here RST0 is 0, RST1 is 008, and RST2 is 0010, RST3 is 0018, and similarly RST7 is equal to 0038H. So that is the restart instructions. Then input output group, this group consists of following set of instructions: in address and out address, and mission control group EI, DI, NOP, HLT, SIM and RIM. So these are the mission control group. So these are all the instructions, students. We have seen all the instructions, and there ends this topic, instruction set. We have seen all the instructions. Please go through all the instructions. Whatever doubt or query you have, students, please approach me. I will clarify your doubt. Thank you, students. And coming to the references, you can refer Godse. That is a very good book. And Ramesh S. Gonkar, Krishnakant are very popular books, but very easily you can understand if you have Godse book. And my material that I will give you will be more than sufficient to understand and write these instructions, students. We stop here. Thank you. We will meet again in timing diagram topic. We will see timing diagram also in video mode. We will complete the unit 3 with in another 2 more sessions. Thank you, students. We stop here.